Hi, I'm Amelia.
And I'm Clive, and we're the Nile Red nerds, and we're going to be showing you how to use a simple dissecting microscope to detect plastics using Nile Red staining. And for that we need to adapt the microscope to measure fluorescence. Nile Red is a dye that binds to hydrophobic materials such as plastics or fats and oils in living material. We dissolve the Nile Red up in methanol at 1 milligram per mil, and that's the solution we're going to use to stain our samples. And here's some examples of plastics which are stained. This is a cigarette butt, cellulose acetate, nylon fishing line, which is a polyamide, a polyethylene plastic that's very hydrophobic and stains yellowy colour, and then a decompostable plastic that also stains but less strongly and more in the red. To induce fluorescence we need a blue light source, an intense source, and we're going to use an LED flashlight which gives out a wavelength around 450 nanometers. These are available online for less than $10 and battery powered.
So, one important thing to note is that a typical AA battery is 1.5 volts, and the batteries we chose to use are rechargeable and they're 3.2 volts, so they're much brighter. The number of the battery that we chose is 14500. Okay, so for the battery charging, we have a rechargeable battery charger that plugs into the wall, and you put your batteries in. So for this battery charger, we've chosen to charge at 2 amps. So for the flashlight, the LED flashlight, you need to be sure to insert the battery correctly or it will short out the flashlight. So you unscrew the top and you make sure and put the positive end in towards the bottom and screw it in.
So we have the batteries in the flashlight, which has 3 settings. Each time you press the little button at the end, it goes between dull, flashing and bright. So we want the bright setting, but as you see the problem is it's illuminating a large area, so we need to make that spot smaller, and we can do that by adding an extra lens. And we get that lens by taking an identical flashlight and unscrewing the lens at the end. So this additional lens we need to attach to the flashlight, and we put the 2 spherical lens parts together with the flat surfaces on the outside, and we first of all attach the lenses via these little flanges with some tape that I've already pre-cut. So there's 3 flanges that we need to attach first. Once that's got the lens in position, you can then wrap some tape around the outside to stabilise the whole thing. So now with the lens attached, you can see that when we turn the light on, it forms a much smaller spot, which is now gives a very bright light for exciting fluorescence. Okay, so the next thing to do is we need to position the flashlight above the scope to illuminate the sample, and for that we can use a tabletop tripod and some hardware as shown here. So to assemble the hardware, first of all need to put this spring clip on the end of the flange. So these are all 1/4-inch tripod screws, 420 screws. We need a lamp fitting in that, which we can then clamp with another screw. Finally, we attach this to the tripod. This tripod is a little unstable, but it works okay if we put the flashlight over one of the legs. The final position we can align once we've got our sample on, so it's best to get it as vertical as possible, forming a small spot in the center of the dish where our sample is going to sit. Okay, so another feature of fluorescence is you need a blocking filter to absorb the blue excitation light and just let the other colors, green, yellow, orange and red, go through into the camera or eyepiece. So we're going to use a yellow filter, and we need to attach that to the objective lenses and using a small magnet. Okay. So we're going to use this tiny magnet, which we want to glue in this position, but to get the polarity of the magnet right, the north and south pole, we're going to use an existing film with magnet already attached, so that it's going to be in the right position. So I need to put a dab of glue on the side here. Press down for about 20 seconds. So there's the magnet now glued.
So for the yellow filter on the microscope, we've found these yellow films, and we just cut them to size to fit the microscope. So I'm wearing gloves because I don't want to get fingerprints all over the film. And for the microscopes at the Sanctuary Exploration Center, the proper size is 8 centimeters by 2 centimeters. And I've done a little pre-cut here so that I can get them to the size I need. Okay, so now we need to put our black electrical tape along the edge of the film so we can handle it without gloves. So now we need to get the little magnet affixed to the film so that it will hold onto the microscope. So you want to line it up to see where you want to put the glue. Get an idea where you want to put it. Add a little drop of glue. Then if you hold this in place, you can kind of drop the magnet on and it'll choose the side it needs to stick to. And you let it sit for about 20 seconds before trying to remove it. So now the last step is to put a piece of tape across the magnet to help hold it in place. So now you can see that it rotates when you need it on and when you no longer need it.
Okay, so now we've got all our components together, we're ready to start to examine the plankton sample. One thing we can do is to put the sample on a laminated piece of graph paper which will give us a millimetre scale, which is useful for checking the lengths of both plankton and any microplastics we find. So that simply rests on the dish, on the microscope there. So our plankton sample, we need to resuspend and fill our petri dish with about 6 millilitres of solution. And then we need to add a drop of Nile Red dye. So this is our Nile Red concentrated solution at 1 milligram per mil. And we've got a dedicated pipette, which we've marked with a bit of tape there so we don't get it mixed up. The Nile Red tends to stain the end of the pipette, and so we keep one especially for the concentrated Nile Red solution. So 1 drop is sufficient. The excess solution back into the stock, and it's a good idea to rinse the pipette tip with isopropyl alcohol so it doesn't build up. So I'm going to put the pipette into the and that will help clean the end of the pipette tip so it doesn't get clogged with Nile Red. So our sample needs to sit for about an hour or so for the Nile Red to stain plastic. So when that's done, we can come back and look for fluorescence. So an hour is now up, so it's ready to start hunting for microplastics in the sample. And here's a standard plastics we added just to check the procedure is working. For more details of how to use this procedure to detect microplastics, please see the protocols described by Amelia in another YouTube video referenced here. And finally, we'd like to thank the people who made this project possible.